Alright, everyone, I made a video before describing 10 best methods for generating synthetic data and why they are important. Today's video is not going to be focusing about that. If you want to watch that video, go back to the previous video, just search on the YouTube or check the playlist. The first video in this series is going to be this video, but today I'm going to focus on implementing this 10 methods in Python with the very best, with the simplest of example, so that you can be able to adopt this. And I'll also share the free code and let me know what you think, and you can take it anywhere and use it in your project. But these are the stuff I discussed last time. You see, I'm talking about the 10 best methods. So I discussed random sampling, I discussed bootstrapping, and then I said data augmentation, also generative adversarial networks, which is GANs. I discussed that. I also talked about, still on GANs, the formula, and then I talked about variational autoencoders, VAEs, and I also discussed them in detail with their mathematical formula. Then I talked about smooth, otherwise synthetic minority oversampling techniques, also the math behind that. Please do watch the video. I'm not discussing that today in detail here. Then we talk about synthetic data via rule-based system, how this works. Today I'm going to implement this in Python, just stay tuned. And then we have noise injection. That's the formula behind noise injection. Yes, that is it. So I'm going to now talk you through some of the best methods, but how to implement this in Python. So I will bring you over to my Jupyter notebook that I've prepared because I don't want this video to be long. So let me see if I can zoom this in to make it a little bit better. Oh, I don't have time. Yes, I still have some time. Excuse me. So this is my Jupyter notebook. So this is random sampling method, and basically in random sampling method, as you heard me discuss last time, I said is in random sampling, what you are basically doing is you are sort of sampling this data just randomly so that you can get some sort of data that you'll be able to use for your work. Just give me one moment and I will be with you. Yes, so I want to be able to tell you why these are important. So yeah, in random sampling, look at this is simple. So you are using just NumPy here alone, and the number of samples you want to create here, I've used some crazy numbers here. I think this is a million, 100 million samples that you want to generate, and then you want to say the mean is 0, standard deviation is 1. You can change these parameters to whatever you want, and then you now come and you're generating synthetic data basically. So you put your mean here, your standard deviation, and the number of samples here. That's it. So the standard deviation, it is the step it will take between each numbers, and then this is how many numbers you want to, what's the range, like number of samples you want to generate, and this should be the mean here, which is 0. We're starting from 0 to this number here. So well, let's see. So and it's that simple. So if I run my code, it should take some time to run because it's generated. You can say 100 million, which you can use for your machine learning, and I'm going to visualize it at the end as well. So it's still running. Let's just give it some time. Yes, now it has generated, and I'm visualizing. I'm viewing the few, just the few 10 samples here. I can also increase it to 20. If I just, oh no, I don't want to do that because it's going to probably take time again to run. Yes, it's because it's going through the cycle, through the loop to generate 100 million samples. It doesn't take time really, basically. But yeah, that is what it is. So this is here. I'm now at least showing just the first 20 samples. Look at the data here. We have 0.3 blah blah blah, 0. Whatever, etc., etc. Now let's look at the length, whether it's actually up to 100 million, what we declare. So I'm just going to check the size of the data here. You can see is 100 million. So let's visualize it even further. So for visualization, I'm just going to use 1000 here. I'm just using 1000 to visualize it, but you can as well use any other size, but I've just used 1000 for now. So number of sample is 1000, following the same description here, the same method, but the remaining thing down here is just to help us visualize it. That's why we're using matplotlib for that one. not really explaining the code in detail here. So let's run this and see. And this is the distribution. So most of the data is around 0. You can see here, this is where majority of the data distributed are. The random sampling here, the normal distribution. Let's still increase it to 1 million and see. So this is 1,000. Already add 5 zeros here. 1, 2, 3, 1, 2. This is also 1 million now, in case you need it for your machine learning training. You know, for your machine learning model, or your or probably what, or your, yes, your machine learning, or you want to use it for something else. But this is it. So this is how the distribution changes, and that is it for random sampling method.